Right, so in this session we're going to talk about floating point numbers in Python, and every language has got its issues, and we're going to expose some of the issues in Python. We're first going to start with, I might even zoom in a tiny bit more, Control Plus, just so that we can get a nice big visual on the screen here. We say that x equals 0.1 and we say that y equals 0.1, and then we say we want to print the value of x and y. So when I run this little piece of code down at the bottom, I've already pre-run it. It says the value of x is 0.1, the value of, oops, there we go, let's change one little error, the value of y is 0.1 as well. We'll just rerun it. And then we can do something like an if statement. So if x equals y, print the values of x and y are the same. Else, let's just copy this. The values of x and y are, let's do that properly. And lo and behold, when we run that little piece of code, we get the values of x and y are the same because we expect them to be the same. So I roll on to this next section over here, and it's exactly the same piece of code, but this time we've got x equals 0.1 plus 0.1 plus 0.1 and y equals 0.3. And we know that 1 plus 1 plus 1 is 3, so 0.1 plus 0.1 plus 0.1 equals 3. So we are expecting to see that x and y are the same values. So let's just try and run this little piece of code, and we run it and we get x and y are different. And this is the first issue that pops up in Python, and we'll go and have a look at this in a bit more detail. But it's also true if I was to do, for example, x, I think this will happen the same, times by 0.3, they should be the same answer. So x equals 0.1 times by 3 and y equals 0.3. So they should be the same answer, but when we print it out, we get that x and y are different. So either way, we've got this difference plus 0.1 plus 0.1 just to return it to its original state. So we can then try and do this with a lot of numbers. So I do exactly the same thing as above, but this time I put it into a for loop here. So we've got I ranging from 0 to the number 9 here. And so x equals 0.1 times I. And the other way of expressing this is, because this is an integer, I will be the value of 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. We've got I divided by 10, which should give us the same result. And inside of that, I've got this print statement here. So we're going to do the same test. That test is going to be inside of the for loop. So we're going to get 10 answers back, ranging from 0 to 9, because the range object iterates through 0 to 9. It starts off at 0. So there's 10 answers that will come back, and we'll see if, like, which kind of errors are they all going to be erroneous, or are some going to be erroneous. Now the clue here is that this one over here at the top, this worked. X and y were the same. It says it over here, x and y are the same. They were tested, they were equal to the same. But here when we did it with 3.3, it wasn't the same. So let's just try and do it over all of the set of numbers. So we'll run that, and we get, and I've actually put this into an F string to be a little bit clearer, and this explains why. So I've put x and y are the same value, or x and y are different, and here it's actually printing out inside the F string the value of x and the value of y. So yes, we get 0 and 0 are the same, 1 and 1 are the same, 2 and 2 are the same, but look at number 3. 3 gets this floating point error, and it's actually 3.000, or multiple zeros, and about 10 zeros in, or if not more, and then a 0.4 at the end. So 3.0004 and 3 are different. So they evaluate to being different. It's okay with 4, it's okay with 5, but then again with 6 and 7, we've got this extra 1 over here in both of these cases, and 8 and 9 are fine. So that's floating point errors in Python. Now, if I was to do something like this, which is, I think it's 2f like that, just to get some floating point decimals, just so that we don't see all of that. 2f, and I believe this is the right way to run this. all of a sudden we get that 0.4, here we go, 0.30 and 0.30 are different. So if we were to do rounding afterwards, we might not see this. So, and that's just formatting the string in the F string itself. So we might not be aware that this problem is coming out when we do various types of print statements that are formatted. So anyway, that's that issue. I wonder what happens if I just increase this to, say, for example, 100. How often does it manifest itself? We'll have all of the same things, I think. So let's just run it. And yeah, here we go. So it works. We know that it's broken there. We know it worked up there, but then one was fine. 1.1 was fine. Again, 1.2 breaks. 1.3 is fine, funnily enough. 1.4 breaks. And we see that these breaks, I mean, is there a pattern to the breaks? It's kind of like 1, 2, 3, 4 successful values over here. There's a string of 3 successful values over here. Then we've got this dot. Let's just view a scrollable element. Let's just view this as a scrollable element so that we can see all of them. And let's just try and inspect this a tiny bit better. But I'm wondering if here, for example, we do see a pattern of 4 come out. So possibly there's some sort of inherent thing that's repetitious in some way. But we'd have to look at that and investigate it a little bit more. But what we do know for sure is that right across the board, like, there are errors that occur. So again, 9.2, for example, it's got this floating point difference over there. The time that it occurred before that was 8.7. So, and the time before that was 8.2. Is there any kind of pattern in between? Is it every 0.5? No, it's not, because the one before that is at 7.8. So it's not even that. And for the most part, these errors appear to have this floating value of just a 1. Although here I notice that on this 7.6 we have a floating value of a 5 here, floating value of a 5. So even that's not consistent in itself. We know here there's one that's got a floating error of 3, a floating error of 4. So they're slightly random on their own too. So I was sticking this into one of the large language models. I use ChatGPT, Python version of it, and it suggests that in order to get this a bit more correct, we can use the isClose method from the math module. So, and if I hover over it, you can, and it basically what the isClose method does is it puts in some tolerance to determine whether 2 floating numbers are close in value. And this is one way of doing it. There is extra arguments that we could put in here, some sort of tolerance level. I wonder if it actually should hover over to what's rel underscore tolerance supports float or index. So we could test it to, like, I don't know, I wonder if I could put in 0.0001, something like that. Let's just test the tolerance like that. No, okay, it's got a type error on that. I'll leave this out for now because I've not used this function fully, but how we actually deploy it. But when we test it here, we get x and y are the same value, and I expect that if I was to take this out of here and then create another module and do a for loop, so for I in range, and then again we'll even do 100, so something like, I'll just do that, put that block of code. You have to do the indentation right in Python, so it'll be that, and then it will be 0.1 multiplied by I in our particular case, and then it was I divided by 10. That kind of gets us a little closer representation, and we can then run it, and then this time we get the same value for everything. Yeah, there is a triple dots here. We could do a scrollable element, but we'll take on fact that everything is the same value, and that's using this isClose method. And I did actually pull it up, so there is a ChatGPT over here, and again I'll zoom in on it a little bit. It's to do with the floating point position errors and identifying values correctly. To avoid these issues, you should use a tolerance-based comparison. The math.isClose function is ideal for this. So we are given a function that does this. Now, I first experienced this in JavaScript, and if there was a reason for leaving JavaScript, that was one of the reasons. But so I discovered it's in Python, and it's probably in multiple other languages. You're welcome to provide feedback on the other languages if you have experience in another language. So it's just something that the coder needs to understand and get used to. This is floating point errors in Python, and it manifests itself, at least to the simplest of levels right up here, where we've tried to do the 0.1 plus 0.1 plus 0.1, and is it equal to 0.3? They are different values. So it's just a pitfall to be aware of when coding in Python and using floating point numbers.